Oh, this is Kevin. I'm a software engineer at Google and graduate from um, the EECS program at UC Berkeley. Go Bears! And today I'm going to be talking about LeetCode number 7, reverse integer. And this is an easy problem. All right, so for this problem, the idea is you're given some integer, 1, 2, 3, for example, and you just want to reverse these digits so that it becomes 3, 2, 1. And works the same way for a negative number. And that seems pretty basic. And then we have one other constraint here that we're in an environment which can only have 32-bit signed integer range, which is from this 2 to the negative 2 to the 31 to 2 to the 31 minus 1. So technically what this would mean is if you're in a system that's like this, then all of your intermediate values while you're calculating cannot be outside of this range. So we'll talk about that in a little bit. All right, so first let's go over how we would do this from a conceptual perspective. So, let's say you have number 1, 2, 3. What you could do is first you take the 3 off the end of it and you put it to the result, and then you take the 2 off, put it like that, take the 1 off, put it like that. And that's kind of like the main idea. That's really all it is. So it's pretty simple. What we do is 123, to take the 3 off of it, you mod with 10, you get 3, right? And so then you take that 3 and you put it on your result. And then you divide by 10, so you end up with 12. So let's say 123 divided by 10, you end up with 12. Okay? Next you take the 12, mod by 10, get the 2. Take your result, multiply by 10 to get 30, and then add the 2. So 30 plus 2, I get 32. And 12 divided by 10 again, get down to 1, and you just take this one, same thing, 32 times 10, get 320, 320 plus 1 from here gives you 321, and that's your answer, right? So that, that seems to make sense, pretty straightforward. Oh, just one thing to mention here, the division is going to be integer division, so this is technically 12.3. We would just use integer division in Python 2. I'm doing this in Python 2, so it'll just round down to 12. And if you're using a language that doesn't do it like that, you can also, there's a floor operator, probably that something along those lines of floor operator. I'm not sure what it would be called in every language, but you can basically do that rounding that way. Cool, so that's how that works for this number. And then I guess for the negative, it's really the same way. Like let's say it's negative 123. We mod by 10, we would get negative 3, and then move the negative 3 to your result, right? And then you divide by 10, you get negative 12, or mod 10, yeah, get negative 2. So this becomes negative 30, plus negative 2 becomes negative 32. And then negative 1, mod 10, you get negative 1, and then this becomes 320, add the negative 1, negative 321. So it works the same way. Cool, so that's basically all it is really from a conceptual standpoint. Cool. So why don't we go, all right, so actually let's talk about there are a couple things that let's point out a couple. I wanted to point out a couple things. So modulus of negative numbers and division of negative numbers. And this is something that's specific to Python 2, right? Which is what we're working on. So I've got this Python interpreter open, and one thing we should just be careful of is, let's say we take negative 123 divided by 10, get negative 13, right? 123 divided by 10, get 12. So this is what we want, right? We just want to get rid of this last digit and make it negative 12. So we want this to be negative 12. So this is kind of annoying. And the reason for this is Python, what this ends up being is negative 12.3, and then it rounds it, it just floors everything down. So negative 12.3 actually goes downward to negative 13, which is one below. It's kind of annoying that it does that. So we can actually fix this by doing negative 12, or negative 123.0 divided by 10, right? And so that makes it into a float, negative 12.3, and then we cast that to an integer. Negative 123 divided by 10.0, right? So this will give us negative 12.3, and then we make that into an integer, and then just kind of chops off the end. So that'll give us negative 12. So for our division, we just got to make sure each time if we're dividing a negative number, then you're going to be making it into a float first, and then casting it as an integer. Don't worry about it too much. In most languages, you probably don't even have to worry about this, but in Python, it's a little bit annoying that we have to. But I'll go ahead and let me just write up, instead of using our divide, we'll have a custom divide. So this is what we'll do. We'll return integer of the number times 1.0 divided by the divider. Right? That's it. It's just a one-line thing. So instead of saying, in our function later, instead of saying 123 divided by 10, we'll say divide 123 by 10, like that. And this will kind of fix that issue with the negative numbers. One other thing too was modulus of negative numbers. So let's say we have negative 123. Let's say we have 123 mod 10, right? We expect 3. We want the ones digit. Negative 123 mod 10, you get 7. So this is annoying because, let's say it's negative 3. It tries to make everything into a positive number, so then it adds the 10 to it and makes it into a 7. So the way the modulus, and this is actually different from, some of the other languages out there. So to get around this, how it works in Python is the modulus operator, whatever sign this second operand is, it'll give the same sign. So you say negative 123 mod negative 10, it'll get a negative number. So then you get negative 3. So that's actually right. So basically what we would want to do is whenever we use the modulus operator, if this front number is positive, we should use a positive value in the back. And if the front number is negative, we should use a negative number in the back. So that we can get the ones placed, the correct sign. So I'll just write a modulus. So mod equals number, m, and if number is less than 0, so if it's negative, then we'll return that number mod by negative m. Otherwise, return number mod m. And so in this case, the m would just be at the positive 10, and it'll just take care of it for us if we get a negative number in the front here. So then again, instead of doing, let's make some space, negative 123 mod 10, we'll just do mod negative 123 by 10, and this will work as expected. Cool. All right, so let's dive in. So if you're working in Python too and you've seen some of these weird behavior, this might be kind of the root cause behind it. So just kind of keep that behavior in mind. You can use some of these functions. Just if you don't understand it, just copy it directly in there, and then it should it should work as expected. All right, so let's go ahead and do the implementation here. And with the implementation, I would also want to say that we want to keep our numbers within this range, right? Negative 2 to the 31 power and 2 to the 31 minus 1. And that's just saying like we have a system that cannot go above that. And technically what would happen is what this really represents is in a computer, I guess in the older times, computers represented integers in 32 bits, 32 ones and zeros. And so this is the highest number it could represent, an integer. And if it were to go above that, it would just wrap around and become a negative. So if you were at this 2 to the 31 minus 1 and you added 1 to it, it would just wrap around and I think it would become 0 or like become the most negative number or something like that. But it just wouldn't work. So you can't store a number higher than that. So we have to make sure that in our, if this was an interview, we'd have to make sure that each of the values in our solution doesn't actually go higher than this number or less than this number. Now, in Python 2, there actually is no constraint. This is kind of like an artificial constraint we're going to put on. So it's possible to write a solution that does not follow this constraint, but still passes the kind of like the checker in LeetCode. But that, in an interview, may not be correct because you're breaking that constraint. So we should just keep that in mind. So our numbers should be between -2 to 31 and 2 to the 31 minus 1. All right, so I'm going to go ahead and just create these variables so I don't have to keep worrying about that. 2 to the 31 power minus 1. And min int is going to be equal to 2 to the 31 power, -2 to the 31 power. And what actually are these numbers? So let's actually, we're going to need this in a second, figure out what these are. All right, so that's this big number, 2, 1, 4, whatever. Right? And then this one is same thing with an 8 at the end. Random aside here, if you're curious why the -1 is slightly higher, it's because in traditional computer science, like how these numbers are represented is a system called 2's complement. And there needs to be a number that represents 0, which is actually just all zeros. And in 2's complement, all numbers that start with 0 are positive, and all numbers that start with 1 are negative. And it's in computers, binary, so it can only be 0 or 1. And so since 0 is taking up one of the positive numbers, then the positive one can't go as high as the negative one. So that's why. Anyways, that's not important for this problem. But all right, so here are the numbers. All right, so now we've gotten all this like stuff out of the way. Let's go ahead and code this algorithm that we described up here. Let's code it up. So basically, let's see here. We're going to have some result. It's equal to 0. And then we are coming in with our x number, right? So that's our input. So while x is not 0, then we're going to do, here's our ones digit. So we'll just say pop. And then we're going to use our mod x by 10 to get the ones digit, right? So that's saying -123 mod 10 is -3. So we get -3 here in pop. And then we do, and then we make sure to divide x by 10 so that now x becomes -12 the next time around. And then we do res equals res times 10 plus pop, right? So we just, let's say it's, we just take our, so let's say it's 0 multiplied by 10, still 0 plus pop, so it starts out at -3. The next time around, we multiply -3 by 10, we get -30, and we add the -2, it becomes -32, and so on. We just keep stacking them on the end. And then that's basically it. And then we return res. So that would essentially do the reverse thing that we wanted it to do, right? Now we have to just make sure that if we're overflowing past these numbers, we return 0. So you might be tempted to do something like this. If res is less than min int, return 0, or res is greater than max int. And this, I think, would actually work in our interpreter, but this is not correct from an interview standpoint. And why? The reason is that this number, what's happening here is this res could overflow, right? It's a number that's higher than max int or less than min int, and it's overflowing while you're in the while loop, and then you check for it afterwards, and then you return 0. So this, if you're actually in a system that was constrained by this, all the numbers within this calculation have to be within here, then you already overflowed at this point, and you don't even know what your number is anymore, because like it's just going to wrap around and become some random number. So then technically this is not correct, but it would work if we throw it into the LeetCode tester. So just keeping that in mind. So how would solve this? So before we do this calculation, we have to make sure that this does not overflow. So there's a couple checks we can do. So let's say we're about to overflow, right? Well, let's say we have this number, and the next number is, if the next number that comes in is a 7, then we don't overflow, we're at the max. But if the next number that comes in is an 8, then we will basically overflow. Or if our current number is bigger than this number, then when we multiply it by 10, it's just going to overflow. So we have to make sure to catch that. So if res is greater than max int, so let's do it like this, divide max int by 10. Right, so this is max int, we divide it by 10, we get this number without the 7 at the end. So if our number is bigger than that, when we do res times 10, it's going to overflow, because everything is just going to be, there's going to be some number in here that's bigger than what we want it to be, so it's going to overflow. So if res is greater than that, it would overflow. Or if res is equal to the same thing, and pop is greater than 7. And what that's saying is, what this is saying is basically, if we're exactly at this number, then what would cause this next number to make us overflow? That would basically be if it's a 7, we don't overflow, but if it's an 8 or a 9, we're going to overflow. So if it's greater than 7, we would overflow. So if that's the case, we'll just break directly out of this loop and return 0. And we can do the same thing again. For the negative case, it's very similar. If res is less than minint, divide by 10, or res is equal to divide the minint by 10, and the pop is less than negative 8, we will overflow, and we'll return 0. Cool. So as opposed to doing the check outside the while loop, we have to do the check before the res gets multiplied and incremented. And so this is actually correct from a standpoint of an interview. So let's go ahead and just try this one out. Okay, so it works for the basic case. Cool. So this one worked. And so that's basically the correct implementation. Let's see here. Let's talk about time complexity and space complexity. So time complexity, actually, big O of n, right? We're going through this while loop. We do this loop one time each for each digit in our number. So it's just a linear thing, and n is the number of digits in our input. And space, we actually don't use any other data structures, so we're basically going to be in constant space. Or we can say that our res, technically, you can say also that if you count the res as the space, you could say it's space of n. So let's just say space of n, asterisk space of constant, depending on whether or not you count your output as space. One thing to note also, I think I saw in the solutions that they said that this was log of k for time. And that's technically also true. What they're saying is log of k where, so I'll put another asterisk here. Log of k, where k is the size of your input, And what that means is, like, let's say, k was, your input's 1,000,000, it's log of k because the 1,000,000 has 7 digits, so the 1,000,000 translates down to 7 if you go by log base 10. And so that's technically, right, so like if it's 1,000,000 versus 1,000, the one that's 1,000,000 won't be 1,000 times slower, it's only going to be 3 extra digits slower. So that's what it's saying, it's log of k. I think it's actually easier to interpret this in terms of n though, so I'm going to get rid of this. Although that's also a correct way of describing it. But if we're going to say O of n, where n is the number of digits, not the size of your input, right? And that's valid. I think this is a little bit easier to understand too, because well, going through the while loop, we do it once for each digit, so it's very straightforward, right? It's a straight one-to-one mapping there. Cool. So this is basically the solution for this problem in Python 2. All right. Let's see here. I also wanted to talk about a few quick gotchas that could happen if you're not careful. So let's comment this guy out and move on to make some space here. So I do sometimes also see. Here, let me update my notes. A solution that is something like this. So this is kind of an example of maybe like a less correct solution. It still would work in the interpreter, but it may be less correct. So okay, so we don't want to deal with negative numbers. We're just going to make our negative numbers positive by using absolute value. We'll just check if it's negative, and then while x pop equals x, pop equals x mod 10, x divided by equal 10, res equals res times 10 plus pop. So this is very similar to like our initial idea. And then if negative res equals negative res, right? So we basically translate all of our negative numbers into positive numbers, and then we can get around that issue that we were describing earlier with with this stuff right here, right? Like when we are doing mod and division by negative numbers in Python 2, we sometimes have some problems. So we can get around it by also absolutely valuing x. And this sort of works, but I think the problem is, let's say you have the most negative possible number, right, for 8, right, whatever this guy is. So let's copy this guy in. And this, if you absolute value this, it becomes this. And this is actually greater than your max positive integer. So you're already getting to the overflow situation. So right here, if you do this and you use this input, you would technically overflow. And then if you were in a system that was truly constrained by all numbers being inside here, you'd have overflowed, and then you would do all this stuff. And you might have it, let's say, the rest of the solution look like this: res x int or res int return 0. So you're doing your check after your while loop. Okay, so you have already overflowed at this point, so you don't really know if res or x is correct. And then when you get to this point, this check won't catch it. If you were truly in a system that was constrained by, that would overflow. So although this technically, I believe this actually works. Let me just test this out. Oh, yeah, let's keep these max int guys in here. All right, so although this technically works, this from the perspective of an interview, they could argue that it is not correct. And then, so that's if we use this, then this use case kind of illustrates the problem. And then let's say we use this input of the most positive number. We're not worrying about the absolute value. What would happen is here we would get into the res, we would go through the loop, and this would just be reversed to like 7, 4, 6, whatever. It's going to be some big number, and then it would overflow, and we would catch it here, and we would return 0 in our interpreter. But again, this is incorrect because the res has already overflowed, and then we're not. If we're really in a system that does not allow for that overflow, then this would not necessarily catch it, and we would just return some random number, and it would be incorrect. So just be careful. I think the thing that's important is to make sure that you, I'll comment this again, you do your check within the while loop before the before your returning value is incremented. And also, you can't use absolute value to get around some of these issues. And that's something that's sort of annoying for Python too. All right, so that's basically how you would, this is the actual solution. This is how you would, here, let me comment this part out. This is how you would do it. This is, correct. And you can justify everything in the interview. And yeah, so hopefully you learned something from this. And if there's anything that didn't make any sense, leave some comments. I'm sure I can answer your questions, or if not, I'm happy to make a follow-up video that will help explain everything. And if there's a specific question on LeetCode that you want me to cover next, again, leave me some comments and I will do those ones next. All right, thanks so much, and best of luck with the interviews.